Now let's find the indefinite integral using a trig substitution of x squared over radical 1 minus 4x squared dx. If you notice, we want to try to put this thing in terms of radical a squared minus x squared. It's going to be a problem because we have a 4 here. It's a problem, but it's solved pretty quickly when we realize that if I factor a 4 out of this whole term, pull a 4 out in front, I'm looking at 1/4 minus x squared, and now I can deal with this. You can put the 4 on the outside if you want. Point is that this is my a squared minus x squared. In this case, a is going to be a half, and our substitution is going to be x equals 1/2 sine of theta. Then dx is equal to 1/2 cosine theta d theta, and then I can start substituting. So we'll leave the 4 in here because it's going to go away really quick. Up top, x squared becomes a quarter sine squared. Dx becomes a half cosine theta d theta. In the bottom, my 4 stays where it is, and we have 1/4 minus a quarter sine squared. So if you notice, I can factor a quarter out of the bottom, and then that slams into that 4 and just disappears. So I'm going to pull an 1/8 out of the top, and then what I'm going to be left with is sine squared cosine over radical 1 minus sine squared, but that just turns into cosine squared, which turns into cosine, and the cosines go away. So we're left with 1/8 sine squared theta d theta. Now, what are we going to do with this? Okay, well, remember your rule for sine squared, sine of an even power. You're going to take it and put it in terms of cosine of 2 theta. The way we do that is to recognize the identity cosine 2 theta is 1 minus 2 sine squared theta. I'm going to push the 2 sine squared theta to the other side and bring the cosine to this side. So it's going to look like that. And then you divide by 2, and then that's going to give me the 1/2 minus a half cos 2 theta d theta. Okay, any derivative of a half with respect to theta is just theta over 2. We could use substitute the 2 theta out, but the net effect is just going to be this turns into sine of 2 theta, and then we just divide by 2, so that'll give me a minus 1/4. Collecting all that is going to give me 1/8 theta over 2, still in parentheses, minus a quarter sine of 2 theta plus a constant. Our original problem is given in terms of x, not theta, so I need to get rid of theta. So let's see what we have. Okay, first off, theta, we notice, since sine of theta is equal to, okay, we'll look at it this way. X equals a half sine theta. If I push the 2 to the other side, that's going to give me sine of theta equals 2x. And then if I want to get theta, that's the same as pushing the sine inverse to the other side. So we get theta as sine inverse of 2x. Cleaning up the bottom here gives me a 16. Okay, for sine of 2 theta, I'm going to have to figure out what's going on with the right triangle. So let's take a look. Okay, if I put in a right triangle, we have sine of theta equals 2x, which is equal to opposite over hypotenuse. So I put a 2x in here and a 1 in there, because remember, 2x can be rewritten as 2x divided by 1. And that's going to mean that our adjacent is radical 1 minus 4x squared. I can work with this almost. Before I can get the sine of 2 theta, I need to pull out an identity. Sine of 2 theta is 2 cosine theta sine theta, and now I can go to work with the triangle. So the cosine is going to be the adjacent over the hypotenuse, and then our sine is, well, we already know the sine, it's 2x, but a check is 2x is going to be opposite over hypotenuse, and that sure works out. So our sine of 2 theta is 4x radical 1 minus 4x squared. So that goes in right here. We're going to crunch that with the 32 to give me x radical 1 minus 4x squared over 8. Then everything plus a constant. So that's our final answer. Of course, we check this. Main reason I check on these here is because I want you to get nimble with how do you crush problems like having the plus 1/2 and minus 1/2 in the same term, things like that. These things are not They're confusing, but if you approach it in an organized manner, it can be handled, well, not easily, but directly. Okay, take my derivatives. Derivative of sine inverse 2x, that's going to be, okay, well, if I put this in a box, it says 1 over radical 1 minus box squared. We're going to stick 2x into the box and then multiply by the derivative of the box, which is going to be just 2. So that's derivative of my first term. For my second term, it's just going to be a product rule. I'll pull the minus 1/8 out in front of it. So what am I going to get? Derivative of the first is 1. Put the second in. Put the first in. And then we want the derivative of the second. That's 1 minus 4x squared to the 1/2. Half comes down. Put in a minus sign. And then multiply by the derivative of the inside, which is minus 8x. So up to here, we have our derivative. So now it's just clean up. Let's take a look at our answer. We want a radical 1 minus 4x squared in the bottom. So that's going to be my clue as to what to multiply by to help crunch this thing down further. It's going to multiply by radical 1 minus 4x squared over itself. So I carry my first term straight down. And then here we're just going to put this in the bottom of each term that shows up. So what's going to happen? When I hit this with the first term, the radical goes away, we just get 1 minus 4x squared. For our middle term here, that's going to go away with this term, which has the minus 1/2. We have a minus 1/2 and a plus 1/2. So that goes away, so we just got to collect what's left over. I have a 1/2 and a minus 8, so that gives me a minus 4. And then I have an x and an x, so I get an x squared. Making sure to keep everything in parentheses so I don't blow these minus signs. That'll be really important that this one hits this one out here. Let's see what happens. Well, we have 1 minus 1 plus 4x squared plus 4x squared. So that's going to leave me with an 8x squared in the top. And then that's going to be over our bottom. Okay, we have the 1/8, which we need to carry, or this doesn't work, so I'll just put the whole thing under 8. So that's going to be the 1/8 comes out down here. We have our denominator here, and then I have an 8x squared up in the top. And then we notice the 8's go away, leaving me with my original integrand. So the check works.